So let's look at 42. And I think I'm on page 5. Yes, I'm on page 5. 42. The sum from I equals 1 through 5 from I plus 2 factorial over I factorial. We can simplify that inside and make it very simple because we know how. So let's give it a shot. How do we simplify? Which of these two is bigger?
Well, we know that I factorial is 1, right?
I factorial, okay. I factorial is, I start with I, multiply by I minus 1, multiply by I minus 2, multiply dot dot, 3 times 2 times 1. It's like n factorial. It's completely unknown. Good, so which of the top or bottom is bigger? That's where we have to start. I equals top. Can anyone tell us how to write the top?
It's I plus 2 times I plus 1 times I.
Factorial. Very good. So now this reduces to what we just did a few minutes ago. So much easier. I didn't have to even use those factorials at all. So then the sum from I equals 1 through 5, from I plus 2, and I plus 1. We can put in the calculator quickly and see what we get. Math, go up, summation, notation from I equals 1, meaning x equals 1, and it goes up to 5. How many terms will the sum have?
4.
1, 2, 3, 4. Very good. Okay, so I plus 1 or x plus 1. Close the parenthesis. I press enter. I got 110. Do you think we need another example with the summation notation and simplify? Or we look at the last topic of sequences? Okay, let's look at one more, 32. When we review, we're going to look at others, of course. I'm sure you're going to find in my math lab. Okay, how many terms now? Let's say I want to list them. Can anyone list those terms for us quickly? And how many terms will you list?
5.
Yes. And the first one is?
I plus 1.
When I is 1.
Oh, 1.
To the plus. When I is 2.
2 to the third.
When I is 3.
Maybe 3 to the third.
When I is 4.
4 to the third.
Very good. Awesome. Good. Get your calculator. Put it in. Go up. And from I equals 1, which means x equals 1, and it goes up to 5. And I would use parentheses. It may or sometimes it needs and sometimes it doesn't. I don't know. Good. I press enter, and I got 225. Do we feel a little bit better about the summation notation now?
Yes.
Okay, final thing about sequences.
I have one quick question.
Yes?
So when you have a
when we do the 1 to the third plus 2 to the third plus 3 to the third?
Yes, we don't have to do this. We are only asked to calculate, but I just wanted to make sure you understand what this means.
Well, I was just wondering, is that called something? Like, is that like expanding or like?
Yes, it's expanding the sum. Yes.
Okay, I just didn't know if there would be a question where it would ask us to do that and then find the answer.
Yes, it could be. Yeah.
So I didn't know what that was called to know.
Yeah, this is the condensed form. We don't want to write this. So what if I have, let's say,
So that's the condensed form then.
yes. So what if I have, for example, this 2k plus 1 cubed from k equals 1 to infinity, which is very possible. Do I want to use this?
No.
You understand what I'm saying?
Yes.
This is the best notation.
I just didn't know if that had a name, that's all.
Oh, no, no, no. It's very good. Very good question. I'm just saying why we prefer this and not this. For 5 terms, it's not a big deal. But what if I have 100?
Right.
That's why we prefer this notation, and that's why we study it. And we study it for sequences. That's why we study it. So that's why I have to present this first and then sequences. And let's see what sequences are. Okay, so sequences. So a sequence is basically a function. A sequence is a function. The domain of the function is only 1, 2, 3, ... Positive natural numbers. And what is the range? Or how does it look? So A1, A2, A3, ... AN, A sub n. This is called a finite sequence. And you can say, okay, wait a minute, what is the connection between what you wrote here and this? It's called finite because it's not infinite. It ends somewhere. It may be from 10 to 1100, but it ends somewhere. That's why it's finite. Versus this one, A1, A2, A3, ... AN ... This is an infinite sequence. Okay, so what's the connection between these two? Same idea with the index. When I is 1 or k or j, I get this term. So that's the input, this is the output. When I equals 2, I get this term. When I is 2, I get A2. When I is 3, I get A3. When I is n, I get AN, and so on and so forth. This is called a general term. And the general term can be given in or sequences can be given to us in 2 ways. 2 ways of presenting sequences. This is way easier than you think. I know it looks like gibberish right now, but you'll see it's as easy as the factorials and everything else. 2 ways of presenting sequences. Number 1, I'm given the general term. General term is given. And I'm going to immediately copy a problem from your book. Number 10. And so this is 10 on page 752. And we're going to work with it in a minute. 3n over n plus 5. Okay, here is another way. The second way is using a recursion formula.
That says n plus 5, right?
Yes. I'm going to write it one more time when we work with it in a minute. Okay, so for that problem, for this situation, I'm going to use, let's say, 18. So we are given A1 equals 5 and AN equals 3 times AN minus 1 for n greater than or equal to 2. And this is problem 18. Yes, I know it looks fantastic right this moment. I just want to put the book away. Okay, so we're given,
What did that say again? The three, that one.
it's A, like this one, not sub n, but sub n minus 1 and minus 1.
Okay, thank you.
So I'm going to get to that in a minute. I'll explain what that is. So let's go back to 10 first. In 10, we are given the general term as 3n over n plus 5. The question is asking us to find the first 5 terms of this sequence. It's given to us, the sequence in this case is given to us with a general term. Which general term? This one. How do we get this one? When we plug in this one, 1, we get the first term. When we plug in this one, we replace n by 2, we get this term. When we replace n by 3, we get this term. So this is the formula for all terms. When n is 1, we get this. When n is 2, we get this. When n is 3, we get that. So coming back here, yeah, they're asking us to find the first 5 terms of this sequence. Fine. I have to find A1. I have to find A2. I have to find A3. I have to find A4, and I have to find A5. Okay. So can anyone give us A1? By comparison, I only have to replace n by 1. Whatever I get will be the first term.
Is it 3 over 6?
3 over 6, which is 1/2. Awesome. For 2. Six over 7. For 3, 9 over 8. With 4, 12 over 9, which is simplified by 3 into 4/3. And with 5, 15 over 10, which simplified by 5 is 3/2. And that's it. That's all we're asked to do. Now let's look at the other one in which we're not given a general term. Or you can say we are given a general term, but in a roundabout way, depending on the previous term. So in problem 18, I copy A1 is given to us as being 5, and A sub n equals 3 multiplied by A sub n minus 1, and minus 1, and obviously for n greater than or equal to 2. Why? Because I'm given A1. I can't find A1 again. The same question, we're asked to find the first 5 terms. So find A1. You can say you already have it, and I'll have to agree. I do. But then I have to find A2. I have to find A3. I have to find A4. And I have to find A5. Let's read what this formula is telling us. The formula is telling me that, for example, if I'm asked to find A10, I have to multiply 3 by A9 minus 1. If I'm asked to find A11, then I have 3 multiplied by A10 and then minus 1. So knowing the pattern, how do I determine A2?
Why is that? Why do you? I think I've lost you. Why are you like doing one less term?
Because that's what the pattern says. AN minus 1 and AN.
Oh,
So A sub 11 depends on A sub 10. So the 11th term is obtained by multiplying the previous term, which is term 10, by 3. And from this answer, I subtract 1 to get A11. So how do I get A2? A2 will be 3 multiplied by what?
5.
Exactly, by A1, which is 5. Awesome. And minus 1. Great job. 15 minus 1, 14. Excellent. How do I get A3?
Three times. Never mind.
14.
Very good. The previous term. If this is 3, then this must be 2. And I have it. It's the previous term. That's what the pattern says. Any term of the sequence is obtained by multiplying 3 by the previous term of the sequence minus 1. For A3, I multiply 3 by the previous term of the sequence and then minus 1. So this is 42 minus 1, 41. How do I get A4?
3 times 41.
Very good. Don't forget the minus 1. Excellent.
And minus 1.
Excellent. Well done. So this is 123 minus 1, 122. Finally, I'm only asked 5 terms. I can go on forever if I want to, but they only want 5.
So it'll be 3 times 122 minus 1.
That's it. So this is 366 minus 1, 365. Awesome. Great job. Any questions? Anyone? Please. Anyone? Any questions? Okay. One more type of problem and it's done. I close the book. Where is it? Okay. And we can practice anything else. We have time to practice more from any of these previous ones. But I just want to finish up with, let's say, 52 and problems like these. In 52, we have 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus 3 dots plus n over 9 to the nth power. And all they want us is to write the summation notation for this. And then we'll have a couple more examples. Okay. So first of all, let's look at the first term. The first term is 1 over 9. And I will say when I is 1. Maybe I have to change that, but for now I'm going to say this is the term that I get when I is 1. Let's look at the second one. I think that, although this can change, I think that this will be when I equals 2. I think that this will be the term when I equals 3. And then what will I be here? What do you think?
Move it down a little bit, please. Thank you.
Sorry.
Okay.
Would it be 8?
So this will be n, right? Because we will go from 1 to 2 to 3 to n.
Oh, it'd be 9?
it will be, look, just don't look at the numerator just yet. 1, 2, 3.
4.
This is infinite,
Oh,
right?
5.
N.
Yeah.
Okay.
Oh, okay.
So then I know for now that when I equals 1, 1 is the lower limit and n should be the upper limit. All terms are fractions, right? We agree? Then I have to have a fraction here. So what do you think we have at the top? Forget about the denominator for a moment. Let's concentrate on the top. Since I have when I is 1, I have 1. When I is 2, I have 2. When I is 3, I have 3. When ... When I is n, I have n. What should I have here?
N.
I cannot use it. N is the last one. I can,
I.
exactly. Exactly, very good. So one more time. When I is 1, I get the 1, correct? When I is 2, I get 2. When I is 3, I get 3. When I is n, I get n. Now let's focus on the denominator. All denominators have a same identical quantity, which is?
9.
9.
Good. And now let's establish what's happening with the power. When I is 1, it appears that the power is?
9.
Power. The power.
Oh, I'm sorry.
That's okay. The power is? What is the power of 9 here?
1.
1.
1,
What is the power of 9 here?
2,
What is the power of 9 here?
3.
And so on and so forth. So what will be the power then? So then we get all those terms.
I.
Very good. Let's check now. When I is 1, do I get 1 over 9? When I plug in this expression, this is our an. This is the general term, which is this, n over 9 raised to the n. When we plug in here 1, do we get the first term?
Yes.
When we plug in here 2, do we get the second term?
Yeah.
Perfect. When we plug in 3 here, do we get the third term?
Yes.
And when we plug in n, do we get the last term?
Yes.
Excellent. That's what they wanted. They wanted us
I
to...
got confused on the end because I was looking at the number instead of the letter.
No worries. No worries. It's the first example. I'm not expecting us to understand everything from the first example. Okay, let's look at 48. This is the last type of problem. No more. This is it. 48. Now we're practicing.
Is that on the same page?
Yes, they're all on 752, 753. Yeah,
Okay.
thank you. Plus ... plus 40. Again, they want us to write the summation notation for this. I'm thinking not all that these summation notations don't have to start with I equals 1. They can start at I equals 4. They can start anywhere, as long as it's a natural positive number.